We have a lot of questions and a lot of things we don't know about the universe, time, black holes, and the beginning of the universe. But with each passing day, we learn more and more thanks to the light. The beginning of the universe and the Big Bang is like a mountain covered with clouds. All of them are very complex and they all seem to work intertwined. As thinkers like Albert Einstein say about time, time is a slippery thing. An article on time and the expansion of the universe was published in the journal Nature. The article caught everyone's attention because the new findings both supported Einstein's general theory of relativity and took us 1 billion years after the birth of the universe. It also gave us an idea of what the universe was like 12 billion years ago. I will explain the situation in a simple way that everyone can understand. Therefore, I would like to give some information in the general culture style. First of all, time and the universe are intertwined. It is very difficult to look at the early times of the universe, because it is light that gives us information about the universe, and light is affected whether it is black holes or radiation, or like any other black hole dampens it. But a quasar or a supermassive black hole is so bright that they shed light on the history of the universe. After the last general knowledge, I will return to our main topic. If you are moving close to the speed of light or if you enter a gravitational field, nothing will change for you, but time slows down for a person looking at you from the outside. In other words, various reasons break time in the universe. Now let's get back to our topic. Exactly 12 billion years ago, scientists proved that time moves like slow motion. They did the work using 190 quasars as clockwork. So what is this quasar? Quasars are massively active supermassive black holes millions to billions of times larger than our sun, often residing at the centers of galaxies. They either swallow the matter attracted to them by their enormous gravitational attraction, or if the incoming matter comes at a certain angle, it starts to revolve around the quasar. When these giant black holes eat something, they release showers of radiation, including jets of high-energy particles. Here scientists compared the luminosity of these quasars at various wavelengths with that of existing quasars and discovered that certain fluctuations occurring today over a period of time were 5 times slower than in the oldest quasars. The lead author of the study published in the journal Nature Astronomy, astrophysicist Geraint Lewis of the University of Sydney in Australia, described the slowing of time.
It's not like everything is in slow motion. If you could be transported back to that time, a second would still seem like a second to you. But from the point of view of today's people, a second back then would open in 5 seconds now. As for quasars, what is observed over time is quasar luminosity. It fluctuates up and down, which is the result of many complex physics in the disk of matter orbiting a black hole at nearly the speed of light. It's bright, it's fading. It's mostly small scale and longer term changes. It's like the stock market with fluctuations and some sharp fluctuations.
So what does the early universe look like for us? But from our position, more than 12 billion years into the future, this early time seems to be drifting, he said, using quasars as clocks in this study, and the results obtained, revealing what happened in the early days of the universe. It is thought that it could help scientists unravel the biggest mysteries about the origin of the universe, how it developed, and what the future holds. Let's go into a little more detail of the work done. The subject of time slowing down to 7 billion years in supernova explosions has already been learned before. In this study, 190 quasars, and these quasars are quasars consisting of hyperactive supermassive black holes at the centers of the first galaxies. By combining observations taken at different wavelengths of green light, red light, and infrared, they were able to standardize the click of each quasar. Applying Bayesian analysis, they found that the expansion of the universe differed from the current ticks of each quasar. In summary, we had an idea about how time moves when the universe is 1 billion years old. Read more about black holes. Is the universe already inside a black hole? You can check out his video. I would like to refer to another study on quasars. Actually, this was published in many newspapers and magazines 2 weeks ago. What I'm talking about is the news that the world, in other words, our universe is moving on an ocean of gravitational waves. This news didn't interest me at first because it's actually not that hard to guess. As a result, the Earth revolves around the gravitational field of the Sun. Then I saw a new study every week about this study and the potential of this study. I did more research on the subject and I want to share it with you because it is also related to quasars. The researchers came to this study by examining 15 years of data from 68 pulsars through multiple telescopes. Pulses from fast-spinning neutron stars reach Earth so predictably that they can serve as accurate clocks. Scientists have been able to detect the presence of gravitational waves since 2015, but they were small and came from relatively small black holes, which they initially collected with the Advanced Laser Interferometer Gravitational Wave Observatory. Astrophysicists have theorized that gravitational waves caused by catastrophic events involving super black holes would be too long and of low frequencies to eject pulsar signals. But the deviation in the pulses is actually so small that it took 15 years to determine that the ripple in space-time really did happen. Think of the universe as a cosmic ocean of waves created by the interaction of massive objects, most likely supermassive black holes. Scientists believe that supermassive black holes, which can be several billion times the mass of our Sun, are at the center of every galaxy, or quasars. What we are measuring is that the Earth is moving in this sea. It wobbles around, and it doesn't just sway up and down, it sways in all directions, researcher Michael Lamb told the Washington Post. This discovery is exciting for many reasons, including that it gives more confidence in Albert Einstein's theory of relativity. Basically, Einstein's theory says that large objects bend the fabric of space-time. If these objects are interacting or moving, they must be sending gravitational waves, which are fast, invisible ripples through space. So, in conclusion, what is the significance of this study? Further research could help scientists learn more about supermassive black holes in general, which provides more insight into the universe. Better understanding the demographics of these supermassive black holes will help us understand how galaxies form and evolve, said Parks PPT researcher Ryan Shannon during the briefing. As reported by Science News, international scientific collaborators will take the next concrete step, combining datasets. They will work to correlate certain gravitational rays with actual black holes observed by regular astronomical paths. This could lead to the first detection of a supermassive black hole binary. It is also planned that in the coming years, NANOGrav's work will move from detection to characterization and production of a spectrum of intensities of waves of different lengths. And as with all new experimental efforts, there will be careful scrutiny for surprises. For example, dark matter, which makes up significantly more than its visible counterpart in the universe, can be detected if it is found in clusters and a cluster passes near the line of sight. If there are exotic objects such as cosmic strings that some extensions of our physical theories allow, their signatures can be detected. That's why scientists are so excited about this discovery that they can find dark matter and pave the way for new studies about our universe. We have come to the end of the video. Do not forget to write in the comments what are your thoughts, especially about the ocean of gravity. Also, don't forget to subscribe and like the channel for science and technology content. Thanks for watching. Peace.